Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 6 from the May-June 2023 paper 4 variant 3. This question is 6a. We're told about a square ABCD where A has coordinates -2, 1 and B has coordinates 1, 5. C has coordinates A, B where A and B are both positive integers. Find the coordinates of C and the coordinates of D. You may use the grid to help you. Okay, so we have A, B, C, D. A has the coordinates -2, 1. So that's A. And B has the coordinates 1, 5. That's B. Okay, the grids are such that they're equal for both sides. That's fine. Okay, it's a square A, B, C, D. So when you have a square or any shape and it's named like in terms of these letters, they normally follow on from each other. So if you have A and you have B, then the next would be C, the next would be D in that order. A, B, C, D. So what do we know about squares? Okay, well, we know that the opposites, a square is a type of parallelogram. So the opposite sides are equal to each other in length and parallel. Okay, so this would be one side, AB. All right. Now, we also know that the sides, so we can say that the side, let's say B to C, okay, BC is going to be the same length as this and parallel to this, okay, but the line joining B to C is perpendicular to the line BA, okay, so we can say that BC has to be the same length as this. So if you think about it, you've got here from -2 to 1 and from 1. So -2 to, sorry, that's the wrong one. That should be over here. My bad, sorry. I made a mistake there when I drew it. Okay, that's better. So you got from -2 to 1 and then 1 to 5. So you can say basically the gradient of the line, which is joining B to C, has to be perpendicular to this gradient. Okay, the gradient, so this gradient, you can say that the gradient of AB is going to be, if you can work out from even the coordinates they gave us, it's going to be 5 minus 1. We can see 5 minus 1 over 1 minus minus 2. 1 minus minus 2, 1 plus 2. That's going to give you 4 over 3. So the gradient is 4 over 3. So the gradient of the line taking us from B to C has to be the negative reciprocal, -3 over 4. So you're going to go 3 down and 4 across. So 1 unit down, 2 units down, 3 units down, and 4 to the right. 1, 2, 3, 4. So this is where C must be for this to be a square. Okay, that's right angles, and that length is the same as that length. This length is, it's like 3 on one side and 4 on the other. It's like a triangle, like 3, 4, 5 triangle. And this is also a 3, 4, 5 triangle if you complete the sides. So C must be at this point over here. Okay, that angle must be a right angle. Okay, so we use the gradient, and I use them with the, if for example, if it came out as 8 over 6, I would have kept it 8 over 6 to get the correct length. Okay, from A to B, you'd have to go, 8 up and 3 across here. From A to B, you got to go 4 units up and 3 to the right. So from B to C, it has to be the negative reciprocal of that. So you've got to go 3 down and 4 to the right. That's going to give you the coordinates of C. And then we can say, okay, from B to A, okay, you can think about it in terms of vectors now if you want. From B to A, I've got to go -3, -4. For C to D, I have to go -3 and -4. Okay, so I'm going to end up here down here, -3, -4. I'm going to end up at this point over here. That's where D is going to be. So D is going to be over here, and we'll end up with our square. Okay, we could have even said from B to C, you've got to go 4 minus 3. From A to D, we've got to go 4 minus 3. Could have done it that way as well. because the opposite sides are parallel to each other. So there's D. So the coordinates of C are 5, 2, and the coordinates of D are 2, negative 2. And we have our square. So we have 5, 2, and 2, negative 2. And that completes question 6, part A. Okay, that's what the student asked me about. Let me just complete the question and do part B. It says P has coordinates negative 1, 3, and Q has a coordinate 6, 4. So this is a different scenario. It's not the same as that. Find the midpoint. Now the midpoint of PQ is going to be given by the average of the x coordinates, so minus 1 plus 6 over 2, and the average of the y coordinates, which is 3 plus 4 over 2. That's going to be 5 over 2, which is 2.5, 7 over 2, which is 3.5. That's the midpoint between those two. Find the length of PQ. Well, we know the length formula is given by the change in the y, change in the x, squared, plus the change in the y squared. So you subtract the x coordinates. You have minus 1 minus 6 all squared. You have 3 minus 4 all squared. That's going to give you the square root of, that's going to be 7 squared, which is 49. Even if it's a negative sign, you square it, it's going to become positive. And that's going to be minus 1 squared, which is 1. So you end up with the square root of 50, okay, which you should write to 3SF in the end. So we're going to have the square root of 50, okay, which gives us 7.071, 7.071. So we round to 3SF, 7.07. Then it says find the gradient of PQ, just to write down the coordinates so that we don't forget. Q is 6, 4. All right, so the gradient of PQ is given by the change in y. So 4 minus 3 over 6 minus 1. That's going to be 1 over 7. So that's the gradient. Then it says find the equation of the line parallel to PQ, which crosses the x-axis at 2. So basically, an equation of a line which has a gradient of 1 over 7 and goes through the point 2, 0. So we can use our formula y minus y1 equals m times x minus x1. If you prefer to use y equals mx plus c, if you want, no problem. If you use this formula, you have y minus 0 equals 1 over 7 times x minus 2. So you have y equals 1 over 7x minus 2 over 7. If you use this form, it's fine. You put the y value as 0 and the gradient as 1 over 7 and the x value as 2 plus c. So you can say c is equal to minus 2 over 7. So we know the gradient is 1 over 7. So y equals 1 over 7x minus 2 over 7. You can leave your answer like that, and that's fine. If you left your answer as 7y equals x minus 2, that's also fine, whichever way you want. But generally, most people would leave it as y equals 1 over 7x minus 2 over 7. And that completes this question. Okay, the question that was really the question of the student was the first one here. Okay, I hope that was clear how we went about and did that. We know that in a square, the sides are equal and they're perpendicular to each other. So the gradient has to be perpendicular, and the opposite sides are equal in length and they are parallel. So we use those properties in order to find the what's the word? To find the coordinates of the other two sides of points on the square. Okay, so thank you for watching. I hope that was clear. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of, I guess this is all to do with really properties of quadrilaterals as well as straight line graphs. I'll put playlist for quadrilaterals, playlist for straight line graphs here. You can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.